Shake Table Lab by Stefan-Cole and Cole Thomas. We started to sketch a plan of a building with slanted sides. To start the construction, we made side beams and cross supports for our first level.
We wanted to slant our tower because we didn't want it to be straight up, because the slanting of the tower would have a better chance to stay up.
We added cross beams so the tower would have more support. Adding our second level to our tower. This is our finished tower. The first floor of our building had to be 18 centimeters, but our project's height exceeded the height with 20 centimeters. Our second floor was 19 centimeters and the base was 18 centimeters squared. We tested our first floor by piling on our sandbags. We got 13 sandbags. That is a total of 3,250 grams. We strengthened the building by adding cross supports and testing it by adding sandbags. The strongest part of our structure is the top of the first story because the way up there is supported by the whole lower part of the building and it has a lower center of gravity. The weakest part of our building is the very top because we ran out of straws, so we didn't put in enough supports.
The amount of tape that we used was preposterous. We added a lot of tape because it would help support our supporters.
This is the minor earthquake.
Yeah, but neither is mine. But yeah, it is. I can see the X's bulging out.
This is the sensor readings for the mild earthquake. Sensor readings tell you how intense the earthquake is. The green is the side-to-side motion of the shake table. The orange is the forward and back motion of the tower. And the green is the up and down of the tower.
It's stable. Wow, this thing is gonna wet.
It's stable, but.
Ooh, Mary got some competition.
How many do you think?
This is the sensor readings for the major earthquake. Building supported 12 sandbags. Our building failed when the sandbags put weight on this mini supporter, and that caused it to push it all the way down to here, and that would cause the building to collapse. If I were to build this over, I would change maybe this cross support, all these mini cross supports all along, because that just adds on more weight to the bottom. I like this project because I like to build things, and I built it with one of my best friends, and I think it's a good project for the rest of the grades that are going to be doing this. Well, for our building, I think cross supports would be the strongest because if you have something in the middle that Cole and I did to ours, the weight would push down, but with cross supports, it would support all the other sides.
Our building supported 6 sandbags. Our building failed when we piled on 12 sandbags onto our building. If we were to build it over, we wouldn't have these vertical supports because it puts too much weight on our cross supports. This vertical support makes the cross supports weak and makes it bend under pressure. This is how our building failed. I like this project because I got to work with one of my best friends and we had a really good time doing it. I also liked it because it was really fun to build and I like building things. I learned that you need to use cross supports on the buildings and you need them to make earthquake-proof buildings.